We've got a post here from Nicoduf asking about overshoot on roll. And Nicoduf, you said it was a blind test and you will not disclose your PIDs, but then I think you must have edited the post to put the PIDs in. So, uh, well, you've given it away. Um, but anyway, we'll take a look and see what I can come up with. You can't really give me a test, because I'm giving away this advice for free, and I never claim to be an expert, just an enthusiastic amateur with an analytical mind. I'm going to get that put on a t-shirt. But I'd love to be wrong, and I'd love to learn. That's, of course, main reason why I started this thread, in addition to just wanting to help people out and help other people get better at this. Um, so let's see what we can see. Here is your log, and we've got 3 logs in here, and if I remember correctly, we'll just double check. Your p-values go from 3 to 3.3 to 3.6. Also, it looks like you're raising your d value to 10 times your p-value. So that is a common guideline for PID controller 1, is to have your your d at about 10 times your p. Obviously fine tune, but that's a sort of starting point. Of course, that only applies if you're using Boris's soft filters. If you don't have soft filters, you simply can't get D that high without having way too much noise uh, in your PID loop and coming out your motors. But you are using soft filters, so you should be fine. So let's take a look now, and I have your roll traces already up, and we'll just take a look at what we see. And so here is a roll. Okay, great. Let's take a look at what we see going into the roll. I see you did a big punch out first. So we've got some noise here as a result of the punch out. And then we go into the roll. We see the P term pushes you into the roll. The D term is proportional to P and leading it. It does not look like there is a ton of noise in D at this point anyway. Your D term cut hertz is 13. The P term pushes strong into the roll, then pushes against the roll, then comes to 0. Guys, if you want to know what a well-tuned roll looks like, I think this is it. Now, that doesn't mean, of course, that there's not room for more tuning. It seems like there's always room for more tuning. But this is sort of canonically speaking what I think a roll should look like. The P term is close to 0 almost throughout the entire roll. And there is a hard push into the roll, which causes an overshoot, which results in a hard push out of the roll, against the roll. So here we're below the axis. The roll is above the axis. So the P term is pushing in the same direction because the RC command and gyro are on the same side of the axis as the P term. And now the PID loop is pushing out of the roll. It's pushing against the roll to slow it down because the P term is on the opposite side. It's below the axis, whereas the gyro and the RC command are above the axis. So we push into the roll, we push out of the roll, then P is close to 0. And because P is close to 0, notice what I does. I is falling and almost reaches 0. When P is close to 0, error is low, and therefore I gets lower. So this is, we really, this is as close to perfect as I think you're probably likely to find in the real world. With the caveat that there's always room for improvements, right? Maybe perfect is too strong a word. At the end of the roll, the stick returns to center. We have a push out of the roll. Again, a slight overshoot, a push the other direction, and now there's a bit of oscillation. So let's find the overshoot. Here is the overshoot. Notice that at this point in time, the stick is centered, but the gyro is still moving the other direction. This is actually our bounce back. I take that back. This is our bounce back. So here the copter is rolling to the left. It is now stationary. So the PID loop did exactly what it was supposed to do. Notice that the copter is stationary at the exact moment that the stick is centered. It doesn't get better than that. But then we have this bounce back. And that's what we're trying to get rid of. Let's take a look now at the next one. Increased P and D. Here we go. Now notice in this case, the P term, let's go back and just make sure I haven't misinterpreted things. Yeah, P and D, close to the axis. Notice in this case, we push into the roll. Notice that D is a little more active here. We push into the roll, we push out of the roll, and now P is positive, pushing into the roll throughout almost the whole turn until the end. And do we have a bigger or a smaller bounce back here? It looks to me like a bigger bounce back. The gyro goes more negative for a longer time. Okay? And finally, what do we see here? Again, P term is positive throughout the whole roll. And now, notice that at the moment the stick is centered, the gyro lags. It lags by not very much, 5.189 to 5.250, so a little less than 1/10 of a second. But here's the moment where the stick returns to center, and here's the moment where the copter is stationary, when the gyro line is centered. And notice now also, well, here the stick moves, so actually we can't draw any conclusions there. We've got an overshoot here. The overshoot is actually smaller in this case. And we're going the other direction. That's fine. Doesn't matter which direction we go. We go below the line. D, or P rather, is positive and then goes negative. So P doesn't stay close to the line during the roll. It's not far off the axis though. This isn't too bad. And okay, that's better. Here we go again. It hits the mark. The PID loop hits the mark perfectly and overshoots. So what should we do here? Well, first of all, which of these three cases is best? And does any of them stand out as better than the others? Between the three, it says the biggest overshoot. It's a little bit unscientific here, of course, because these things are not identical. The second one does hit the mark. We hit 0 rotational rate as the stick returns to center and overshoot. It actually is a fairly big overshoot as well. I got to tell you, the three of these scenarios don't look substantially different to me. I would, of course, feel differently if I had video. So as far as the p-value goes, I like the fact that on this one, the p-value is close to the axis and again, we see the same thing here, so there's some consistency here. P-value here, it's close, it crosses over. D is relatively close to the axis. Here we have some oscillation. Oh, these are just little bobbles one side to the other, not flips. Yeah, I think of these three, the first one with the lower p-value of I think 3.0 has the cleanest sort of trace with the p-value, with the p term most closely approximating the correct angular rate. But I'm not convinced that that actually is resulting in less overshoot. I have dealt with overshoot by increasing D, And as soon as I went from standard CleanFlight 1.9 to Boris's an early version of Boris's firmware that just had the D-term filter, my rolls immediately switched to being basically perfect. So I think the D-term filter may be the place to look for answers. Your D-term doesn't look very noisy. You could always experiment with lower D-term cut hertz. You're at 13 now, maybe try a 10 or 11 and see if that improves things. That may allow you to increase your D value. You could also try increasing D. I think your D right now is between 30 and 36. Try increasing it to maybe 40 or 45 and see if that helps with the overshoot. The other thing Boris has said is that it relates to latency. So he said that low latency makes for less overshoot because the PID loop can respond quicker. I'm not sure about whether that would help. We know that copters can have good rolls with your current settings and your current setup. And we see that the PID loop is hitting its mark. In other words, it's not that it's behind the curve in any way because the gyro line is hitting 0 at basically the same time as RC command. So the copter is hitting its mark in terms of when the stick is centered, the copter is stopped. It's just that the PID loop is a little bit behind in that it's bouncing back. That again suggests to me that the D term may be the place to look for the answer because the D term leads the P term. So the D term so right now we're exactly hitting our mark and overshooting, and it may be the case that increasing D the D will head off that overshoot and allow us to sort of slide into home instead of overshooting. So that's the direction I'm looking at. Do you have any oscillations at the higher P values? Yeah. So you see here we've got now we're at very high throttle, so maybe TPA is the answer here. But this is less good. We have more vibrations. Might like to see a little more filtering here. D-term is basically tracking P though, so it may just be that you need a little TPA to pull P down and D down. Yeah, see if we look here, notice that although the D-term is swinging around, it is more or less tracking P. It's not moving when P doesn't move, and that's kind of what we want to see. So it feels like your filtering is actually pretty close to right. You could always try, I think if you increase D to try and improve the bounce back, you may need a little more filtering. Yeah. All right. Well, that's what I got. I hope it's helpful. Happy flying. Bye-bye.